Picture this. You look up at the night sky, tracing the familiar constellations you've known since childhood. But one by one, the stars begin blinking out of existence. Not a cloud in sight, no explanation, just gone. Now imagine if those vanishing stars weren't cosmic accidents, but deliberate acts, the ultimate cosmic hide and seek, played by civilizations far beyond our understanding. What if the universe's greatest disappearing act wasn't magic or natural phenomena, but the signature of someone or something, tampering with starlight itself? Across our galaxy, astronomers are documenting stars that vanish without a trace, defying everything we know about stellar lifespans. Today, we're diving into one of space's most electrifying mysteries. Are we witnessing cosmic glitches? Or could we be seeing the first evidence that advanced civilizations have learned to turn off their suns like light bulbs? From Dyson spheres to alien megastructures, we'll explore how star hacking might not be science fiction, but our first glimpse of neighbors who don't want to be found. The universe might be playing the ultimate magic trick, and we're about to pull back the curtain. Now let's turn our gaze to the evidence that sparked this cosmic detective story. The vanishing star phenomenon isn't just theoretical, it's etched in the observational records of puzzled astronomers worldwide. One of the most compelling cases centers on a star catalogued as Tabby 611-1162-1. This unassuming star in the constellation Orion was perfectly visible in early sky surveys, shining steadily like countless others. Then, when scientists pointed their telescopes back to its coordinates years later, something astonishing happened. It simply wasn't there anymore. Not dimmed, not shifted, gone, without any of the explosive fanfare we'd expect from a dying star. What makes this disappearance so baffling is how clean it was. When massive stars reach the end of their lives, they typically go out with a bang, either in a supernovae, bright enough to outshine entire galaxies, or by collapsing into black holes with telltale bursts of radiation. But Tabby 611-1162-1 left no debris, no shockwaves, no trace whatsoever. It's as if someone flipped a cosmic light switch. Astronomers first stumbled onto these anomalies while comparing historical photographic plates with modern digital sky surveys. Projects like the Vanishing and Appearing Sources during a Century of Observations, or VASCO, have methodically combed through old astronomical images, flagging stars that no longer appear in current observations. Out of millions of catalogued stars, a handful like our mystery in Orion have seemingly vanished from their expected positions. Initial theories ranged from the mundane to the extraordinary. Some suggested data glitches, perhaps a cosmic ray hit the camera sensor, creating a false star in early images. Others proposed dark, cold objects like brown dwarfs might have drifted in front of the star, blocking it from view. But as more vanishing stars were documented with similar disappearances, these explanations started showing cracks. If obscuring dust clouds or instrumental errors were to blame, why didn't the stars later reappear? Why no residual heat signatures? The silence was deafening. This isn't just about one missing star, it's a pattern that challenges our understanding of how stars behave. Normal stellar physics can't easily explain how an object millions of times more massive than our Sun could vanish without releasing enough energy to trigger every detector in the galaxy. Yet here we are, staring at empty patches of sky where stars once burned steadily. As we'll see next, even the most creative natural explanations struggle to account for these cosmic disappearing acts, leaving the door wide open for possibilities that defy conventional astronomy. Now let's explore the cosmic rulebook, what ordinary stellar physics says should happen when stars vanish. Nature has its own bag of tricks for making stars disappear, and some of them are just as dramatic as any alien megastructure. Take failed supernova, for instance. When massive stars run out of fuel, their cores can collapse straight into black holes without the usual fireworks. Instead of erupting in a blinding supernova, the star implodes quietly, like a building crumbling inward. The result? A black hole where a star once shone, with no explosive evidence left behind. It's a compelling explanation, except for one problem. Even these so-called quiet deaths should produce gravitational waves or lingering infrared glow from falling debris. Yet in cases like 2Z6-111-1162-1, we've detected neither. Then there's the dust cloud theory. Imagine thick cosmic curtains drifting between us and a distant star, dimming it to invisibility. Interstellar dust exists everywhere, and dense pockets could theoretically blot out starlight temporarily. But here's the catch: dust doesn't vanish without a trace. It absorbs starlight and re-emits it as heat, creating telltale infrared signatures. When astronomers scanned the void where our missing stars once burned, their infrared telescopes found nothing but cold, empty space. Black hole formation offers another possibility. If a star collapsed directly into a black hole, its light would wink out abruptly. But black holes aren't perfect cosmic vacuums. They pull in surrounding matter with such fury that the infalling material heats up and glows fiercely. That means even a freshly formed black hole should leave behind a faint accretion disk, like embers after a fire. Yet multiple vanishing stars have left no such afterglow, disappearing as cleanly as erased chalkboards. Some astronomers propose rogue planets or brown dwarfs, failed stars too small to ignite might photobomb our view. These dark, wandering objects could eclipse stars for decades. But eclipses end, the obscuring object moves on, and the star reappears. That's not what we're seeing. These stars don't return. They're gone as if they never existed, challenging even the most flexible natural explanations. The universe is full of stellar magic tricks, but every illusion has its limits. While physics gives us plausible ways for stars to disappear, none quite match the peculiarities of these real-world cases. Missing heat signatures, absent debris, and permanent vanishings pile up into a cosmic contradiction, one that might require rewriting the stellar rulebook, or looking beyond it entirely. Now let's consider another angle. What if the stars never vanished at all? Sometimes, the mystery lies not in the cosmos, but in the tools we use to observe it. Telescopes, after all, are human-made machines, and like any technology, they're prone to glitches, gaps, and gremlins in the data. Take telescope malfunctions, for instance. A misaligned mirror or a faulty sensor can make a star appear to flicker or vanish entirely. In 2009, the Kepler Space Telescope briefly lost dozens of stars due to a stuck reaction wheel, a component that helps steady its gaze. Engineers fixed the issue and the stars reappeared, but for a tense period, it seemed like cosmic objects were blinking out of existence. Even ground-based observatories aren't immune. A speck of dust on a lens, a software bug, or a power surge can create phantom disappearances, leaving astronomers chasing shadows. Data processing errors add another layer of confusion. Modern astronomy relies on algorithms to sift through mountains of observations, and sometimes these programs trip over their own logic. In 2018, researchers flagged a star that seemed to dim erratically, sparking speculation about alien megastructures. The culprit, a glitch in the data pipeline that misaligned light measurements. Once corrected, the star's behavior snapped back to normal. These digital hiccups are like cosmic typos, small mistakes with big implications. Then there's the challenge of observational gaps. Stars don't teleport away, they fade or vanish over time. But if a telescope only checks in sporadically, it might miss the gradual dimming and record a sudden disappearance. Imagine watching a sunset through a flickering camera. You might catch the sun high in the sky one moment and gone the next, even though it actually sets smoothly. Historical sky surveys, especially older ones with limited coverage, can create these false vanishing acts. History offers sobering lessons. In the 1960s, astronomers reported a star in the constellation Monoceros had disappeared. Decades later, sharper telescopes revealed it was still there, just obscured by a previously unnoticed dust cloud. More recently, the lost star TUDSI 2211-327-1 turned out to be a cataloging error. The star had been mislabeled, not erased. These cases remind us that before we blame aliens or rewrite physics, we should double-check the instruments. Yet even after accounting for these errors, some vanishings stubbornly resist explanation. When multiple telescopes, across different wavelengths, confirm a star's disappearance, and no technical glitch can be found, the mystery deepens. It's a cosmic whodunit where the usual suspects keep getting ruled out, leaving us with fewer answers and more questions. So while instrumental errors explain many false alarms, they don't solve the puzzle entirely. The universe, it seems, still has a few tricks up its sleeve. Now let's step into the realm of speculative science, where imagination meets astrophysics. If instrumental errors can't explain every vanishing star, could something far more extraordinary be at play? Enter Freeman Dyson, a visionary physicist who proposed an idea as daring as it is mind-bending, the concept of a Dyson sphere. Imagine a civilization so advanced that it outgrows the energy limits of its home planet. To fuel its expansion, it might turn to its star, the ultimate power source. Dyson's idea was simple yet revolutionary: an enormous megastructure built around a star to capture its energy output. Picture a vast network of solar panels or even a solid shell enveloping the star, siphoning its light and heat. Such a structure wouldn't just power a civilization, it could fundamentally alter how the star appears to distant observers. Here's where things get fascinating. If a Dyson sphere were partially built, it might block swaths of starlight, causing the star to dim erratically. A complete sphere could render the star nearly invisible, emitting only waste heat detectable as infrared radiation. This isn't just science fiction. Scientists actively search for these technosignatures, unusual infrared emissions paired with missing visible light, as potential evidence of alien engineering. Critics argue that building such a megastructure defies our understanding of materials and engineering. But proponents counter that a civilization capable of harnessing stellar energy would operate on a scale we can barely comprehend. They might use nanotechnology, self-replicating machines, or even manipulate matter in ways that seem like magic to us. The beauty of Dyson's hypothesis is that it's testable. Projects like glimpsing heat from alien technologies survey the skies for stars with excess infrared heat, a possible smoking gun for cosmic construction projects. Of course, absence of evidence isn't evidence of absence. We've yet to find a confirmed Dyson sphere, but the search continues, and while natural explanations often prevail, the allure of this idea lies in its audacity. It challenges us to rethink not just vanishing stars, but the very limits of what's possible in the universe. So next time you hear about a star mysteriously fading, ask yourself, could it be nature's handiwork or the signature of a civilization bending starlight to its will? Moving from the theoretical to the observed, let's turn our attention to one of the most enigmatic stars in modern astronomy, KIC 8,462,852, better known as Tabby's star. Discovered by citizen scientists in the Kepler mission data, this star quickly became famous for its bizarre and unprecedented dimming patterns. Unlike the predictable dips caused by orbiting planets, Tabby's star dimmed erratically, sometimes losing up to 20% of its brightness for days or weeks at a time. These sudden, dramatic drops defied conventional explanations, sparking a firestorm of speculation, including the tantalizing possibility of alien megastructures. Initial excitement centered around the idea that the star's light was being blocked by something artificial, perhaps a partially built Dyson sphere or a swarm of energy collecting satellites. The irregular dimming didn't match the smooth, symmetrical patterns expected from natural phenomena like planets or dust clouds. Researchers even considered whether a vast construction project with unevenly spaced panels or debris could explain the star's erratic behavior. For a brief moment, it seemed like humanity might have stumbled onto evidence of an advanced civilization at work. But science thrives on scrutiny, and subsequent studies poured cold water on the alien megastructure hypothesis. Detailed observations revealed that the dimming was wavelength-dependent, meaning the star's light dimmed more in some colors than others. This pointed strongly toward natural causes, like interstellar dust or cometary fragments, rather than solid megastructures. Dust particles scatter shorter wavelengths of light, like blue, more than longer ones, like red, a signature that matched Tabby's star's behavior. Further analysis suggested that a family of giant comets or a circumstellar dust cloud could account for the star's odd light curves without invoking extraterrestrial engineering. Yet the mystery isn't entirely solved. Some researchers argue that the dust explanation doesn't fully account for the star's long-term dimming, which has been observed over centuries-old photographic plates. Others propose that the dust itself could be debris from shattered planets or even the remnants of a catastrophic collision in the star's system. What makes Tabby's star so compelling is that it embodies the tension between extraordinary claims and rigorous skepticism. It's a reminder that while nature is often stranger than fiction, the truth usually lies in the details we've yet to uncover. So where does this leave us? Tabby's star remains a cosmic puzzle, one that challenges our assumptions and keeps the door open for both natural and artificial explanations. Whether it's a swarm of comets, a rogue dust cloud, or something even more exotic, this star continues to captivate astronomers and dreamers alike. And that's the beauty of science. Every anomaly is an invitation to explore, question, and wonder what else might be hiding in the light of distant suns. While Tabby's star remains one of the most famous cosmic mysteries, it's far from alone in its strange behavior. Stepping beyond this well-known enigma, astronomers have spotted other stars with equally baffling dimming patterns, each presenting its own unique puzzle. Take VVV-WIT 07, for example. This star, located in the crowded galactic bulge, was observed by the Vista telescope in Chile to dim by an astonishing 80% before gradually brightening again. Unlike the irregular dips of Tabby's star, VVV-W8007 dimming was deep and prolonged, lasting for months. The sheer depth and duration of this event left researchers scratching their heads, as no known natural phenomenon, like a planet or even a dust cloud, could easily explain it. Some speculated it might be caused by an unusually dense, asymmetric dust disk orbiting the star, but even that theory struggles to account for the extreme dimming observed. Then there's EPIC 204,278,916, a young star in the Scorpius constellation that stunned astronomers with its erratic light fluctuations. Over the course of one observation period, this star's brightness dropped by an incredible 65% for nearly a full day. What makes EPIC 204,278,916 particularly intriguing is its age. It's surrounded by a protoplanetary disk, the kind often associated with planet formation. Some scientists proposed that massive clumps of dust or debris within this disk could be blocking the star's light in unpredictable ways, but others point out that even these explanations fall short, as the star's dimming events are far more extreme than what typical planet-forming material should produce. Could this be another case of natural oddities, or is there something more at play? Comparing these stars reveals just how much they challenge our understanding of stellar behavior. Tabby's star's dips are sporadic and deep. VVVWIT07 dimming is slow and prolonged, and EPIC 204,278,916 changes are sudden and extreme. Their light curves, the graphs tracking their brightness over time, don't match anything seen in conventional astronomy. Planets, dust clouds, and even stellar pulsations follow predictable patterns, but these stars defy expectations at every turn. That unpredictability is what keeps astronomers both fascinated and frustrated. Yet, the search for answers continues. Projects like the Vanishing and Appearing sources during a century of observations, VASCO, are scouring historical sky surveys for more of these cosmic anomalies, hoping to find patterns or commonalities that might unlock their secrets. Could they all be part of a new, undiscovered stellar phenomenon, or might some of them, despite the odds, still hint at something far more extraordinary? For now, these stars remain tantalizing reminders that the universe still holds plenty of mysteries waiting to be solved. And as we uncover more of them, each strange flicker in the night sky invites us to look deeper, question harder, and wonder just what else might be hiding among the stars. Now, let's shift our focus to the broader hunt for clues, what scientists call technosignatures. These are the telltale signs of advanced technology in space, the cosmic breadcrumbs that might lead us to intelligent life beyond Earth. Unlike traditional searches for radio signals or alien messages, technosignatures cast a wider net, looking for any unnatural or engineered phenomena that stand out against the backdrop of the universe. And here's where vanishing stars enter the picture. If a star's light is being artificially dimmed or redirected, that could be one of the most dramatic technosignatures imaginable. So, what exactly do scientists look for when hunting these cosmic fingerprints? For starters, unusual light patterns are a major red flag. Natural stars dim and brighten in predictable ways, like the rhythmic pulses of variable stars or the temporary dip caused by a planet passing in front. But when a star's light curve defies all known physics, as we've seen with Tabby's star or VVVWIT07, that's when eyebrows raise. Could these anomalies be the result of megastructures, like Dyson spheres, built around stars to harvest their energy? Or perhaps an advanced civilization is using some form of stellar engineering to cloak their presence intentionally? These scenarios might sound like science fiction, but they're taken seriously in the search for extraterrestrial intelligence. Another key technosignature is infrared excess. If a civilization were building massive energy, collecting structures around a star, the waste heat would be detectable as an unusual infrared glow. Astronomers have scanned several suspicious stars for this very signal, including Tabby's star, though no definitive evidence has been found yet. Then there's the idea of artificial transits, deliberate, repeating patterns in a star's dimming that could serve as a beacon or communication. Imagine a civilization manipulating starlight in precise, mathematical ways to signal its existence. It's a long shot, but one worth considering. The search for extraterrestrial intelligence has evolved far beyond just listening for radio waves. Today, projects like Breakthrough Listen and the previously mentioned vanishing and appearing sources during a century of observations, VASCO, are scanning the skies for these and other technosignatures, from laser pulses to industrial pollution in distant atmospheres. The goal isn't just to find aliens, it's to identify anything in the cosmos that doesn't fit the natural order. Vanishing stars, with their unexplained behavior, fit neatly into that category. Whether these mysteries are caused by advanced civilizations or undiscovered natural phenomena, they remind us that the universe is full of surprises. And as our tools and methods improve, we might just stumble upon the ultimate discovery, proof that we're not alone. This brings us to the next big question: how would a civilization even pull off such a feat? To explore that, we'll need to delve into the Kardashev Scale, a way of classifying advanced societies by their energy use. Because if stars really are being manipulated, the beings behind it would have to be operating on a scale beyond anything humanity has achieved. To truly grasp the scale of what we're talking about, let's step into the mind of Nikolai Kardashev, a visionary Soviet astronomer who gave us a way to measure civilizations not by their art or politics, but by their energy consumption. His Kardashev Scale is a humbling reminder of how small we are in the cosmic scheme of things, and how much further others might have gone. At the bottom of the scale, a Type 1 civilization has mastered all the energy available on their home planet, something humanity is still centuries away from achieving. But the real intrigue begins with Type 2. These civilizations don't just tap into their planet's resources, they harness the entire output of their star. Picture a society building megastructures like Dyson swarms, countless solar collectors orbiting their sun, capturing every scrap of light and heat. For beings at this level, stars aren't just distant lights, they're power plants, and their energy could fuel technologies we can barely imagine. Now, here's where it gets fascinating. If a Type 2 civilization wanted to hide, manipulating starlight wouldn't just be possible, it might be trivial. Think about it. If you can build structures that encircle a star, redirecting or dimming its light would be like adjusting a thermostat. They might use vast mirrors or light-bending materials to cloak their star from prying eyes. Or perhaps they'd emit artificial light patterns to mimic natural stellar behavior, disguising their presence entirely. But why would they bother hiding? The motives could range from caution to outright strategy. Imagine a universe where advanced civilizations are common but dangerous. Staying hidden might be a survival tactic, a way to avoid attracting attention from potential threats. Alternatively, they could be observing us from afar, adhering to something like the zoo hypothesis, where they deliberately avoid contact to let us develop undisturbed. Or, more chillingly, they might be hiding because they've learned that broadcasting your location invites trouble. The sheer scale of such engineering is mind-bending, but the physics checks out. A civilization capable of harnessing a star's energy could theoretically alter its appearance in ways that defy natural explanations, And that's precisely why vanishing stars are so tantalizing. If we ever found a star that dimmed or disappeared in ways that matched these predictions, it wouldn't just rewrite astronomy textbooks, it would change everything we know about our place in the cosmos. As we ponder these possibilities, another wild idea emerges. What if these civilizations aren't just hiding stars, but actively reshaping them? That leads us to the next frontier of speculation: black hole farms and star lifting, where the line between nature and technology blurs beyond recognition. Now, let's venture into one of the most mind-bending possibilities of all: black hole farms. If a civilization can harness the energy of a star, what's stopping them from manipulating something even more extreme? Imagine a society so advanced that they don't just build solar collectors around stars, they create and control black holes. It sounds like science fiction, but the physics behind it is surprisingly solid. Black holes, often seen as cosmic vacuum cleaners, could actually be the ultimate power sources. A small, artificial black hole, say, the size of a mountain, would emit something called Hawking radiation, a slow leak of energy as the black hole evaporates. For a Type 2 civilization, this could be a near-limitless energy supply. They might position these tiny black holes near their star, using the radiation to fuel their megastructures or even siphon matter directly from the star itself. But here's where things get eerie. If a civilization were farming black holes, the side effects could explain some of the vanishing stars we've observed. Picture this: as matter falls into a black hole, it heats up and emits intense radiation. If multiple black holes were clustered around a star, they could distort its light in strange ways, dimming it, flickering unpredictably, or even making it vanish entirely from our telescopes. The star wouldn't be gone. It would just be obscured by the chaotic energy of these artificial black holes, and the implications don't stop there. If a civilization were using black holes to harvest energy, they might also be manipulating spacetime itself. Black holes warp light through gravitational lensing, bending it like a funhouse mirror. An advanced society could exploit this effect to cloak their star, redirecting its light so it never reaches us. From our vantage point, the star would simply wink out: no debris, no explosion, just an inexplicable disappearance. This idea isn't just wild speculation. Physicists like Freeman Dyson and Stephen Hawking have seriously discussed the potential for artificial black holes as energy sources. Of course, creating one would require technology far beyond our grasp, perhaps the ability to compress matter into a singularity or harness energies comparable to a supernova. But for a civilization that's already mastered stellar engineering, it might be just another tool in their cosmic toolbox. So, the next time astronomers spot a star behaving strangely, dimming in ways that defy explanation, it's worth asking, could we be seeing the shadows of black hole farms? It's a reminder that the universe might be far stranger and far more engineered than we've ever dared to imagine. And with that, we turn to another radical idea: star lifting, where civilizations don't just hide their stars, but reshape them entirely. Now, let's shift our gaze to another staggering idea: star lifting. If a civilization can harness black holes, why stop there? Imagine reaching into the heart of a star itself, siphoning off its raw materials like cosmic miners. This isn't just science fiction. Star lifting is a theoretical process where an advanced society could literally extract matter from a star, reshaping it for their own needs. Picture a civilization so advanced that they don't just orbit their sun, they tame it. The mechanics behind star lifting are as fascinating as they are complex. Stars are colossal furnaces, fusing hydrogen into helium and releasing unimaginable energy. But what if a civilization could tap into that process? One method might involve using powerful magnetic fields or focused energy beams to pull plasma from the star's surface. Another approach could deploy vast arrays of orbital mirrors or lasers to heat specific regions, creating controlled eruptions that eject material into space. Once harvested, this stellar matter could fuel megastructures, power interstellar travel, or even build new artificial worlds. But here's the catch for astronomers: star lifting wouldn't go unnoticed. Removing mass from a star would alter its behavior in detectable ways. For instance, if a star loses too much hydrogen, its fusion reactions could slow down, causing it to dim prematurely. Alternatively, the extracted material might form a glowing disk around the star, scattering light in unusual patterns. Some stars might even flicker erratically as their outer layers are systematically stripped away. These wouldn't be natural stellar phenomena. They'd be the fingerprints of a civilization reshaping its sun. There's precedent for this in nature. Stars like Beta Lyrae exhibit strange, rapid mass loss that puzzles scientists. Could some of these outliers actually be evidence of star lifting in action? It's a tantalizing thought, and the implications stretch even further. If a civilization is mining their star, they might also be fine-tuning it, prolonging its lifespan by reducing its fuel consumption or even steering its evolution to avoid a catastrophic supernova. The scale of such engineering is almost beyond comprehension, yet for a Type II civilization, it might be routine. Think of it like interstellar agriculture, cultivating a star not just for light and heat, but for its raw materials. And if they're doing it covertly, they might deliberately mask their activities, making their star appear unstable or dimming it just enough to evade casual detection. This brings us back to the mystery of vanishing stars. Could some of these disappearances be the work of civilizations quietly harvesting their suns? It's a radical idea, but in a universe this vast, radical might just be the norm. And as we peer deeper into the cosmos, each strange flicker or unexplained dimming becomes a potential clue, a whisper of something extraordinary happening in the dark. Next, we'll connect these cosmic puzzles to one of astronomy's greatest enigmas, the Fermi paradox. If advanced civilizations are out there, why haven't we seen them? Could vanishing stars hold the answer? Now, let's step back and ask a bigger question. If advanced civilizations are out there, why haven't they made contact? This is the heart of the Fermi paradox, famously summed up by physicist Enrico Fermi's simple yet haunting query: where is everybody? The universe is unimaginably vast, with billions of stars and planets, many older than Earth. Statistically, intelligent life should have emerged elsewhere long before us. So why does the cosmos feel so silent? The mystery of vanishing stars might hold a clue. One possibility is that advanced civilizations aren't just hiding, they're deliberately avoiding us. Think of it like a cosmic game of hide and seek. If a society reaches a certain technological level, it might recognize the risks of broadcasting its existence. Hostile aliens, resource competition, or even unintended cultural disruption could make stealth the smarter strategy. This idea isn't new. Astronomers call it the zoo hypothesis, the notion that Earth is intentionally left undisturbed, like an exhibit in a galactic wildlife preserve. But vanishing stars take this a step further. If a civilization has the power to manipulate starlight or harvest entire suns, they might also have the ability to cloak themselves completely. Imagine a universe where the most advanced societies don't build megastructures to shout their presence. they engineer their stars to disappear, leaving no trace. It's a chilling thought, and it's not the only explanation. Another theory, the dark forest hypothesis, suggests the universe is like a dark forest where every civilization is a silent hunter, terrified of revealing its location. In this scenario, any detectable signal or structure could attract predators, so the safest move is to stay hidden, even if it means dismantling stars to stay off the radar. There's also the transcension hypothesis, which proposes that advanced civilizations don't colonize space, they transcend it. Maybe they upload their consciousness into digital realms or retreat into black holes, leaving physical reality behind. If that's true, vanishing stars could be signs of civilizations transitioning to states we can't even perceive. But here's the twist: if hiding is the norm, then our search for extraterrestrial intelligence might be looking for the wrong things. Instead of radio signals or Dyson spheres, we should be hunting for stars that blink out unnaturally, for cosmic engineering masked as stellar quirks. The silence of the universe might not mean we're alone. It could mean we're surrounded by civilizations too cautious to say hello. Next, we'll journey into the past, where ancient myths of disappearing stars might hold echoes of these very mysteries. Now, let's turn the clock back and consider something fascinating. What if the mystery of vanishing stars isn't just a modern discovery? What if ancient cultures witnessed these cosmic disappearances and wove them into their myths? From Aboriginal Dreamtime stories to Babylonian clay tablets, there are eerie accounts of stars vanishing without explanation. Could these be early records of the same phenomenon puzzling astronomers today? Take the Aboriginal peoples of Australia, for example. Their oral traditions, some dating back tens of thousands of years, describe celestial beings or creator spirits that vanish from the sky. One story from the Yolngu people tells of a star named Julpan, part of the Orion constellation, which suddenly disappeared. In their lore, it was taken by ancestral spirits. Modern astronomers have noted that the stars in Orion do, in fact, exhibit unusual variability. Could Julpan's disappearance be an ancient observation of a star dimming or vanishing? Then there's the Babylonian Enuma Anu Enlil, a series of clay tablets documenting celestial events over centuries. One tablet mentions a star that was there and is no more, with no explanation given. Babylonians were meticulous astronomers, tracking planetary movements and eclipses with surprising accuracy. For them to note a star's disappearance as extraordinary suggests it was anything but a common event. Fast forward to today, and we have stars like TUISI 6111, 1162-1 observed in one sky survey, gone in the next. The parallels are hard to ignore. Even in medieval Europe, chroniclers like the Venerable Bede wrote of stars that faded from sight or were extinguished like a torch. At the time, these were often interpreted as divine omens, but with our modern understanding, could these have been natural or unnatural stellar phenomena? The 11th century, Chinese astronomer Shen Kuo documented a guest star in the Crab Nebula that brightened dramatically, then vanished. We now know this was a supernova, but other accounts don't fit so neatly. Here's where it gets intriguing. Many of these ancient myths share a common thread: the idea that celestial changes were acts of powerful beings. Whether gods, spirits, or ancestors, the sky was seen as a realm of agency, not just random events. Modern science dismisses these as superstition, but what if they were early attempts to explain something real? If advanced civilizations can manipulate starlight, could ancient cultures have glimpsed the aftermath, stars winking out, with no natural cause in sight? Of course, skeptics argue these stories are just folklore, shaped by limited understanding. But consider this: before telescopes, humans relied on the naked eye. A star's disappearance would have been startlingly obvious, especially to cultures that mapped the sky for navigation or agriculture. The Dogon people of Mali, for instance, knew of Sirius's invisible companion star long before telescopes confirmed it. Their knowledge, passed down orally, suggests some ancient observations were eerily precise. So, are these myths mere coincidences, or could they be fragments of a deeper truth? If vanishing stars are evidence of cosmic engineering, perhaps our ancestors saw the first clues. Up next, we'll examine how modern projects are scouring old sky surveys, using artificial intelligence to hunt for these elusive stellar ghosts. Now, let's fast forward to the present day, where cutting-edge technology is giving us new ways to chase these cosmic mysteries. While ancient cultures recorded vanishing stars in myths and clay tablets, modern astronomers are armed with digital sky surveys and artificial intelligence to hunt for these elusive stellar ghosts. One of the most ambitious efforts is the Vanishing and Appearing Sources During a Century of Observations project, or VASCO. This international collaboration combines old photographic plates from the 1950s with modern digital sky surveys, comparing them to spot stars that have disappeared or suddenly appeared. The goal: to find anomalies that defy conventional astrophysics, perhaps even signs of advanced extraterrestrial engineering. What makes VASCO unique is its sheer scale. The team has analyzed nearly 1 billion objects across the sky, looking for anything that doesn't fit the expected patterns, and here's where artificial intelligence steps in. Sifting through decades of astronomical data manually would be impossible, so researchers train machine learning algorithms to flag potential candidates. These systems can spot subtle changes in brightness, position, or even the complete absence of a star that was once there. But VASCO isn't alone. Other projects, like the Legacy Survey of Space and Time at the Vera Rubin Observatory, are preparing to scan the entire visible sky every few nights. This relentless monitoring could catch stars in the act of vanishing or reappearing, giving astronomers unprecedented real-time data. Then there's the Gaia mission, a space observatory mapping the Milky Way with astonishing precision. While its primary focus is stellar motion, Gaia's data has also revealed strange objects that don't behave like normal stars. Some exhibit erratic brightness changes, while others simply disappeared between observations. Could these be natural phenomena or something more? Of course, the challenge isn't just finding missing stars, it's ruling out mundane explanations. Telescope glitches, data artifacts, or even asteroids passing in front of stars can mimic disappearances. That's why researchers cross-check anomalies across multiple surveys and instruments. The gold standard, a star that vanishes in one dataset but is confirmed absent in others. So far, VASCO has identified around 100 potential vanishing stars, with a handful defying easy explanation. One standout case involves a star that appeared in a 1952 plate but was gone by 2012. No supernova remnant, no black hole signature, just silence. The implications are thrilling. If even one of these anomalies turns out to be artificial, it could rewrite our understanding of the universe. But until then, scientists remain cautious, prioritizing rigorous verification over sensational claims. What's next in this high-tech hunt? Upcoming telescopes like the James Webb Space Telescope could peer deeper into these mysteries, analyzing the light of vanishing stars for chemical fingerprints of advanced technology. Meanwhile, AI grows smarter, learning to distinguish between cosmic oddities and potential technosignatures. The search for vanishing stars bridges ancient wonder and modern science, a reminder that the sky still holds secrets waiting to be uncovered. And as technology advances, we might finally answer the haunting question: are we alone, or is someone out there, hiding in plain sight? Now, let's take a closer look at why solving this cosmic puzzle isn't as straightforward as it might seem. Hunting for vanishing stars comes with its own set of unique challenges, each one adding layers of complexity to the search. First, there's the sheer vastness of space. The Milky Way alone contains hundreds of billions of stars, and astronomers are observing only a tiny fraction of them in detail. Even with advanced surveys like VASCO or Gaia, the amount of data is overwhelming. Imagine trying to spot a single light bulb flickering out in a city of billions, except the city is spread across unimaginable distances, and the light might have vanished decades before we even noticed. Then there's the issue of time. Stars don't just wink out instantly, at least not naturally. If a star disappears, it could be due to a slow process like dimming over centuries or a sudden event like a collision. But without continuous, long-term monitoring, we might miss the critical moment. Historical records help, but they're often incomplete or inconsistent. A star might appear in one old photograph but be missing in another, simply because of differences in telescope sensitivity or atmospheric conditions on the night it was observed. Data quality is another major hurdle. Early photographic plates weren't as precise as today's digital sensors, and even modern instruments can produce false positives. Cosmic rays hitting a telescope's detector, for example, can mimic the appearance of a star where none exists, or a glitch in data processing might accidentally erase a real star from the records. Distinguishing between a genuine disappearance and an instrumental error requires painstaking cross-checking across multiple sources, a time-consuming process with no guarantees. Then there's the challenge of natural explanations. Space is full of phenomena that can mimic a vanishing star. A dense cloud of interstellar dust might drift in front of a star, blocking its light temporarily. A faint star could be eclipsed by a passing asteroid or another star in a binary system. Even gravitational lensing, where a massive object bends light, can distort or magnify a star's appearance, making it seem like it's vanished when it's really just hiding behind cosmic trickery. Even when all these factors are ruled out, confirmation is difficult. If a star disappears, how do we know it's not just moving? Stars drift over time, and without precise tracking, a star might simply shift out of a telescope's field of view. Proper motion studies help, but they require years of data to confirm a star's trajectory, and by then, the star might already be gone. Perhaps the biggest challenge is the silence of space. If a star truly vanishes without a trace, there's often no residual evidence, no leftover heat, no expanding debris, no telltale radiation. A failed supernovae might collapse into a black hole without the usual fireworks, but even then, we'd expect some gravitational or X-ray signature. A complete absence of any signal is what makes these cases so baffling and so tantalizing. Despite these obstacles, astronomers persist because the potential payoff is enormous. Finding even one confirmed case of a star vanishing unnaturally could revolutionize our understanding of the cosmos. Until then, the search continues a delicate balance of patience, precision, and a willingness to question everything we think we know about the stars above. And as technology improves, perhaps these challenges will become a little less daunting, bringing us closer to unraveling one of the universe's most intriguing mysteries. Now, let's zoom in on one of the most baffling cases in this cosmic mystery, the star known as Tabby 611-1162-1. This particular star has become a focal point in the search for vanishing stars, and for good reason. Its disappearance is so puzzling that it has left astronomers scratching their heads and rethinking what we know about stellar behavior. The story begins with historical sky surveys. Back in the 1950s, this star was clearly visible in photographs taken by the Palomar Observatory Sky Survey, a massive project to map the night sky. It appeared as a typical, unremarkable star, nothing out of the ordinary. But when astronomers went back to look for it decades later using more advanced telescopes, it was simply gone. No trace, no explanation, just an empty spot where a star once shone. Multiple teams have tried to redetect it since then, each time coming up empty. The Swedish led Vanishing and Appearing Sources during a century of observations, or VASCO, project specifically targeted this star, combing through decades of data to confirm its disappearance. Even with today's powerful instruments, like the Pan-STARRS telescope in Hawaii, there's been no sign of it, and that's what makes this case so compelling. The star didn't just dim or move. It vanished without leaving behind any of the usual clues. So what could have happened? One possibility is that it collapsed directly into a black hole without going supernova. Most massive stars end their lives in a spectacular explosion, but in rare cases, theorists suggest a star could implode silently, leaving no visible aftermath. If that's what occurred here, it would be one of the few documented instances of such an event. The problem: we'd still expect some gravitational or X-ray evidence, and so far, there's none. Another theory is that it was obscured by an unusually dense cloud of interstellar dust. But this explanation has its own issues. Dust clouds tend to drift over time, and if one had blocked the star, we'd expect it to eventually reveal the star again, unless the dust cloud was impossibly vast and static, which seems unlikely. Plus, no such cloud has been detected in its vicinity. Then there's the more speculative idea that this star didn't vanish naturally at all. Could an advanced civilization have built something around it, like a Dyson Sphere or another megastructure, effectively hiding it from view? It's a radical thought, but the lack of any natural explanation keeps this possibility on the table. Of course, without direct evidence, it remains in the realm of fascinating speculation rather than confirmed science. What makes Tabby 611-1162-1 so important is that it forces us to confront the limits of our knowledge. Stars aren't supposed to just disappear, yet here we are, staring at a cosmic blank spot where one used to be. Whether the answer turns out to be a rare astrophysical event or something even more extraordinary, this case reminds us that the universe still holds mysteries we're only beginning to uncover. Next, we'll explore how scientists are using advanced simulations to test these theories, modeling the possible fates of stars to see if any match what we've observed. Could these digital experiments finally provide the clues we've been searching for? To uncover the secrets behind vanishing stars like Tabby 611-1162-1, scientists are turning to the digital realm for answers. By harnessing the power of supercomputers, they're running intricate simulations that recreate the lives and possible deaths of stars under every scenario imaginable. These virtual experiments are like cosmic detective work, testing each theory to see which one fits the baffling observations. One of the most compelling simulations explores the idea of a star collapsing directly into a black hole without a supernova. In these models, when a massive star runs out of fuel, its core implodes under its own gravity, forming a black hole so quickly that the outer layers of the star are swallowed without the usual fireworks. The simulation predicts a sudden, silent disappearance, no explosion, no lingering nebula, just an empty patch of sky. But here's the catch. Even in this scenario, astronomers should detect a burst of gravitational waves or a faint X-ray echo as the star vanishes. The fact that we haven't seen these signals around 26111-1162-1 makes this explanation intriguing but incomplete. Then there's the dust cloud theory. Simulations show that if a dense, localized cloud passed between Earth and the star, it could block the star's light entirely. But for the effect to last decades without shifting, the cloud would need to be both incredibly dense and unnaturally stable, a cosmic oddity. Even more puzzling, advanced telescopes should have spotted such a cloud by now, yet surveys reveal nothing unusual in that region of space. Now, let's venture into the realm of artificial scenarios. Imagine an advanced civilization building a Dyson swarm, a constellation of energy collecting satellites encircling their star. Simulations of this megastructure suggest it would gradually dim the star's light in specific, unnatural patterns. Unlike a dust cloud, which scatters light randomly, a Dyson swarm would block light in a way that doesn't match any known astrophysical process. Some models even predict subtle infrared emissions from the structure's waste heat, a potential technosignature, while no such infrared excess has been detected around 2D6111-1162-1. The absence isn't definitive proof against it, just a missing puzzle piece. But how do we tell the difference between a natural vanishing act and an engineered one? Simulations highlight key clues. A natural disappearance, like a failed supernova, would leave behind traces in gravitational waves or X-rays. An artificial one, like a Dyson swarm, might show unnatural dimming patterns or infrared anomalies. Right now, the lack of any secondary evidence makes both scenarios speculative, but future telescopes could change that. Projects like the Vera C. Rubin Observatory, with its unprecedented sky-scanning power, might catch a star in the act of vanishing, giving us real-time data to compare against these models. What's fascinating is that these simulations aren't just about solving a single mystery, they're expanding our understanding of stellar behavior itself. By testing extreme scenarios, scientists are discovering gaps in our knowledge, like whether stars can truly vanish without a trace naturally. Each simulation is a stepping stone, either ruling out possibilities or revealing new ones we hadn't considered. As we push the boundaries of these digital experiments, one thing becomes clear: the universe is capable of surprises that defy our textbooks. Whether the answer lies in undiscovered physics or something beyond our current imagination, these simulations are lighting the way forward. Next, we'll examine another wild card in this cosmic puzzle. Could dark matter, the invisible glue holding galaxies together, play a role in making stars disappear? The simulations are about to get even more intriguing. Now, let's turn our attention to a shadowy player in this cosmic mystery: dark matter. This invisible substance makes up roughly 85% of the universe's mass, yet it eludes direct detection, revealing itself only through gravitational effects on galaxies and light. Could this enigmatic force be behind the vanishing stars? One provocative theory suggests dense clumps of dark matter, known as dark matter halos, might be drifting through our galaxy. If one passed in front of a star, its gravitational pull could bend and distort the star's light, potentially making it vanish from our view temporarily. Unlike ordinary matter, dark matter wouldn't scatter or absorb light. It would warp spacetime itself, acting like a natural lens. But here's the catch. Such lensing events should magnify the star's light before dimming it, creating a telltale brightening we'd notice. For 2AC6 111-1162-1, no such flicker was observed, leaving this idea on shaky ground. Then there's the possibility of exotic dark matter particles interacting with stars in unexpected ways. Some physicists speculate about asymmetric dark matter, a hypothetical type that could accumulate in a star's core over millennia. If enough built up, it might trigger a catastrophic collapse, causing the star to implode silently. No supernova, no leftover nebula. Simulations of this process show it could mimic a failed supernova, but without the expected gravitational wave signature. Yet, like all dark matter theories, this remains speculative without direct evidence. Another fringe idea involves primordial black holes, theorized remnants from the early universe that could be as small as an atom yet as massive as a mountain. If one collided with a star, it might consume the star from within, leaving no trace. While intriguing, the odds of such an event are astronomically low, and we'd likely detect telltale X-ray bursts as the black holes devoured stellar material. What makes dark matter such a compelling alternative to alien megastructures is that it's already part of our cosmic ledger. We just don't understand it fully. Unlike hypothetical Dyson swarms, we know dark matter exists from its gravitational fingerprints on galaxies. But until we pin down its true nature, its role in stellar disappearances remains an open question. Future experiments like the Vera C. Rubin Observatory could tip the scales. By scanning the sky for subtle light distortions, it might catch dark matter halos in action or rule them out entirely. Meanwhile, particle detectors deep underground continue hunting for dark matter's elusive signals. If either effort bears fruit, we could rewrite the rules of stellar evolution. No aliens required. So while dark matter offers fascinating possibilities, it's still a puzzle missing critical pieces. Whether it holds the key to vanishing stars or not, exploring its potential reminds us that the universe still has secrets even stranger than fiction. Next, we'll ponder an even bolder question. Could these disappearing stars be deliberate acts of interstellar communication, or something far more ominous? The theories are about to take a startling turn. As we venture deeper into the cosmic unknown, let's explore a possibility that blurs the line between science and science fiction. Could vanishing stars be more than just natural anomalies? What if they're deliberate acts of communication, or even a cosmic game of hide and seek? The idea that advanced civilizations might manipulate starlight intentionally opens a Pandora's box of thrilling and unsettling scenarios. One provocative theory suggests these disappearances could be interstellar signals, a deliberate attempt by an advanced civilization to get our attention. Imagine a species so far ahead of us that they've mastered the ability to dim or brighten stars at will, crafting a celestial Morse code across the galaxy. Instead of radio waves or laser pulses, they might be using the stars themselves as their canvas. But why? It could be a greeting, a warning, or even a test to see if we're observant enough to notice. The erratic dimming of stars like KC 8462852, with its unpredictable patterns, has led some researchers to wonder if we're witnessing an attempt at contact. On the flip side, what if the vanishings aren't signals but a form of cosmic camouflage? If a civilization wanted to hide, whether out of caution, secrecy, or defense, manipulating starlight would be an effective strategy. A Dyson swarm or similar megastructure could not only harness a star's energy, but also cloak its presence, making the entire system invisible to distant observers. This raises eerie parallels to the zoo hypothesis, the idea that advanced beings might be intentionally avoiding contact, leaving humanity undisturbed in a kind of interstellar nature reserve. But the ethical dilemmas here are staggering. If vanishing stars are indeed signs of intelligent activity, should we respond? Broadcasting our location could invite curiosity or catastrophe. History warns us of the risks when advanced and less advanced civilizations meet. The principle of dark forest theory, popularized in science fiction but rooted in real scientific caution, suggests the universe might be a dangerous place where civilizations stay silent to avoid attracting predators. Even more unsettling is the possibility that we're already being observed. If a civilization can hide stars, they might already know we're here, studying us from the shadows. Projects like SETI, which actively search for extraterrestrial signals, could be walking a fine line between discovery and danger. The debate isn't just philosophical, it's urgent. With humanity's own signals leaking into space through radio and television broadcasts, we've already begun announcing our presence. The question is whether we should amplify that signal or adopt a more cautious approach. Some scientists argue for active SETI, deliberately sending messages to potential neighbors, while others warn it's akin to shouting into a dark forest without knowing who or what might be listening. As we stand at this crossroads, the vanishing stars remind us that the universe is stranger and more mysterious than we ever imagined. Whether they're natural oddities, cosmic messages, or something far more deliberate, one thing is clear: the answers could redefine humanity's place in the cosmos. Next, we'll examine how the public and scientific communities have reacted to these mind-bending theories, from skepticism to wild speculation. The conversation is just getting started. Now, let's turn our attention to how the world has reacted to these mind-bending ideas about vanishing stars. The response has been as varied and unpredictable as the phenomena themselves, revealing a fascinating collision of skepticism, excitement, and everything in between. Scientists, for their part, have approached the vanishing star theories with cautious curiosity, while many astrophysicists acknowledge the gaps in our understanding of stellar behavior. Most hesitate to leap straight to extraterrestrial explanations. The scientific method demands evidence, and so far, natural causes like dust clouds or observational errors are still the leading theories. Yet even the most skeptical researchers admit the allure of these ideas. After all, if even a single vanishing star turned out to be artificial, it would revolutionize our understanding of the cosmos. Some, like those involved with the SETI Institute, have taken the possibility seriously enough to scan these stars for technosignatures, though no definitive signals have been found yet. The media, on the other hand, has often swung between sensationalism and dismissal. Headlines declaring alien megastructure found generate clicks, but they also risk oversimplifying the science. Outlets that dive deeper often highlight the tension between astronomers who champion bold hypotheses and those who urge restraint. Yet this back and forth isn't entirely negative. It keeps public interest alive, encouraging funding for further research. Stories about stars like KAC 8462852 have even inspired documentaries and popular science books, bridging the gap between academia and mainstream curiosity. Public reactions have been even more diverse. Online communities buzz with theories, from sober scientific discussions to wild speculation. social media platforms light up whenever a new vanishing star study drops, with armchair astronomers and sci-fi fans alike weighing in. Some see these cosmic mysteries as proof we're not alone, while others fear what advanced civilizations might mean for humanity's future. The debate often mirrors broader societal divides. Optimists view potential contact as a chance for collaboration, while pessimists warn of existential risks. One thing is certain, the conversation is evolving. As telescopes grow more powerful and AI helps sift through vast datasets, we may soon have clearer answers. Until then, the vanishing stars remain one of the most tantalizing puzzles in modern astronomy, a mystery that challenges our science, sparks our imagination, and keeps us all looking up at the night sky with wonder. Next, we'll explore how cutting-edge technology is stepping up to solve this cosmic riddle, with future telescopes poised to peer deeper into the unknown than ever before. Stepping into the future, the key to unraveling the vanishing star's mystery may lie in the next generation of astronomical tools. Groundbreaking telescopes and missions are set to revolutionize our search for answers, offering unprecedented clarity and precision. Leading the charge is the Vera C. Rubin Observatory, a facility poised to scan the entire southern sky every few nights with its massive mirror and cutting-edge camera. This relentless survey will create a living map of the cosmos, flagging any stars that flicker or vanish with unmatched sensitivity. Unlike past telescopes constrained by limited observation time, the Rubin Observatory's continuous monitoring could catch vanishing stars in the act, distinguishing between natural dimming and potential artificial patterns. Then there's the James Webb Space Telescope, already transforming infrared astronomy from its vantage point a million miles from Earth. Webb's ability to peer through cosmic dust clouds, often blamed for obscuring stars, could rule out natural explanations in puzzling cases. Its spectroscopic instruments might even detect unusual chemical signatures around suspect stars, like industrial byproducts from megastructures. While Webb wasn't designed to hunt for alien engineering, its extreme precision makes it an accidental detective for technosignatures. The telescope's analysis of bizarre objects like KAC 8462852 has already reshaped debates, proving that next-gen tools can turn speculation into testable science. On the horizon, projects like the European Extremely Large Telescope promise even sharper views. With a mirror nearly half the length of a football field, this behemoth could resolve details around distant stars that were previously blurry pixels, perhaps spotting irregularities in starlight caused by artificial structures. Meanwhile, initiatives like the Square Kilometre Array Radio Telescope Network might eavesdrop on civilizations advanced enough to manipulate stars, seeking engineered signals hidden in the noise of the universe. What makes this era thrilling is how these tools complement each other. Rubin's wide-angle surveys will identify anomalies. Webb and its successors will zoom in for forensic analysis, and radio telescopes could listen for accompanying signals. Together, they form a cosmic detective agency working to crack the case. Within the next decade, as data from these missions floods in, we may finally distinguish between cosmic illusions and something far more profound, whether starlight itself has been hacked. The answers, it seems, are written in the sky. We just needed the right tools to read them. Now, let's pause for a moment and imagine a scenario that could redefine our place in the cosmos. Suppose one of these next-generation telescopes, the Rubin Observatory, the James Webb Space Telescope, or perhaps another yet to be built, captures undeniable proof that a star's disappearance isn't natural, but the work of an advanced civilization. The confirmation would send shockwaves through every corner of human society, science, and philosophy. First, consider the scientific revolution that would follow. For centuries, astronomy has operated under the assumption that the universe follows natural laws we can observe and predict. Discovering that some stars vanish by design would upend that framework overnight. Astrophysicists would scramble to reinterpret decades of data, questioning which other cosmic anomalies might be artificial. The very definition of natural phenomena would expand, forcing us to reconsider what's possible in the universe. Laboratories and universities would pivot urgently, with funding flooding into the search for more technosignatures. The field of astrobiology, once speculative, would become one of the most critical branches of science. But the societal impact might be even more profound. History shows that humanity struggles with existential shocks, from Copernicus displacing Earth from the center of the universe to Darwin challenging our origins. Proof of star-hacking aliens would dwarf those revelations. Some would react with awe and inspiration, seeing it as proof we're not alone. Others might feel fear or vulnerability, confronted by civilizations capable of engineering stars while we're still bound to our planet. Governments could face pressure to reveal whether they detected similar evidence before, sparking debates about transparency and secrecy. Religious and cultural beliefs would grapple with the implications, some adapting seamlessly, others facing profound crises of meaning. Philosophically, the discovery would force us to confront uncomfortable questions. If advanced civilizations exist, and some choose to hide why, are they avoiding us intentionally, like the zoo hypothesis suggests, or is hiding a survival strategy in a universe where advanced beings perceive others as threats? The Fermi paradox's famous question, "Where is everybody?" might shift to, "Why are they hiding?" Ethical dilemmas would arise too. Should we attempt to communicate, risking exposure to potentially hostile actors? Or would silence be the wiser choice? Then there's the practical side. Industries would race to replicate or defend against such technology. Energy companies might explore how to harness starlight, as these civilizations do, while military strategists could fret over the defensive implications. Pop culture would explode with new stories, songs, and art trying to process the revelation. Meanwhile, global collaborations like SETI would gain unprecedented public support, uniting humanity in a shared mission to understand our cosmic neighbors. Ultimately, the discovery would remind us of how small we are and how much we have yet to learn. It could either unite humanity under a common cosmic identity or deepen divisions as we debate how to respond. But one thing is certain, the night sky would never look the same again. Every twinkling star might carry the haunting question, is this one real, or is it being controlled by something beyond our understanding? The search for answers would become the defining journey of our species. With that in mind, let's turn to the skeptics, who argue we're getting ahead of ourselves. Are these vanishing stars really evidence of alien engineering, or are there simpler explanations we're overlooking? Now, shifting our gaze to the other side of the debate, let's examine the most compelling counterarguments from skeptics who remain unconvinced that vanishing stars point to alien intervention. These voices remind us that extraordinary claims require extraordinary evidence, and so far, the cosmic breadcrumbs we've gathered are still open to interpretation. One of the most powerful tools in the skeptic's toolkit is Occam's razor, the principle that the simplest explanation is usually the correct one. When we observe a star disappearing, Is it more plausible to invoke an unknown, advanced civilization manipulating starlight, or to consider the countless natural processes we already understand? Stars can dim or vanish due to mundane reasons like dust clouds, stellar collisions, or the star's own life cycle. Even rare events like failed supernovae or the sudden collapse into black holes, while not fully understood, fit within the known laws of physics. Jumping to alien megastructures risks overlooking simpler astrophysical phenomena that might explain the observations just as well, if not better. Another key criticism revolves around the lack of direct evidence. While the idea of Dyson spheres or star-lifting civilizations is thrilling, no telescope has ever captured unambiguous signs of engineering on a stellar scale. The strange dimming patterns of stars like KIC 8462852, initially hailed as potential alien megastructures, were later attributed to circumstellar dust. Similarly, other candidate stars with unusual behavior often have natural explanations that emerge with further study, without a smoking gun, like a star flickering in a way that defies all known physics. Skeptics argue we're projecting our hopes onto cosmic randomness. Detractors also highlight the immense energy and coordination required to manipulate starlight. Even for a Type II civilization capable of harnessing a star's power, hiding an entire star would demand technology so advanced it borders on magic by our standards. Wouldn't such a civilization leave other detectable traces, like waste heat or communication signals? The absence of these secondary signs makes the hacked starlight theory feel more like science fiction than science. Some astronomers point to observational biases too. Telescopes have limited lifespans, and gaps in data can create false mysteries. A star might seem to vanish simply because we stopped looking at it for a decade, or because instruments glitch. Projects like VASCO, which compare historical sky surveys, help weed out these errors, but they remind us that human tools are imperfect. Perhaps the most sobering critique is time. The universe is old, around 13.8 billion years, while human astronomy spans mere centuries. What we perceive as a vanishing star might be a routine cosmic event we've simply never witnessed before. Expecting to recognize alien engineering in this vast timeline with our limited data could be hopelessly arrogant. Yet even skeptics agree these mysteries are worth investigating. The debate isn't about shutting down curiosity, but grounding it in rigorous science. As we'll see next, that balance between wonder and skepticism is what keeps the search for cosmic truths alive. Now, let's turn to a question that lingers in the shadows of this cosmic mystery. If vanishing stars truly are the work of advanced civilizations, should humanity even try to reach out? The ethical dilemmas here are as vast as space itself, forcing us to weigh curiosity against caution and wonder against wisdom. Imagine stumbling upon a civilization so advanced they can cloak entire stars. Their technology would dwarf ours, their intentions utterly unknown. History on Earth teaches us that when more advanced societies encounter less developed ones, the outcomes are rarely equal. Cultural contamination, where one society's norms overwhelm another's, is a real risk. Would our attempts to communicate unintentionally disrupt their way of life, or worse, expose us to existential threats? The physicist Stephen Hawking famously warned against shouting into the cosmic dark, comparing it to Native Americans encountering Columbus. The consequences, he argued, didn't work out so well. But silence carries its own perils. If these civilizations are hiding, they might view any attempt to contact them as a breach of their privacy, or even a hostile act. Think of it like sneaking up on someone in the dark. Even if you mean no harm, your sudden appearance could provoke fear or aggression. A civilization capable of manipulating starlight might possess defenses or weapons beyond our comprehension. The mere act of detecting them, let alone signaling our presence, could invite unintended retaliation. On the other hand, what if their silence is an invitation? Some theories, like the zoo hypothesis, suggest advanced civilizations might be deliberately avoiding contact to let humanity evolve undisturbed, like observers in a cosmic sanctuary. If that's the case, reaching out could be akin to tapping on the glass of our enclosure, risking the end of our protected status. Yet, others argue that growth requires risk. If we never dare to communicate, we might forever remain in cosmic isolation, missing out on knowledge, collaboration, or even salvation. After all, a civilization that can hide stars might also have solutions to challenges like climate change or resource scarcity. There's also the question of who speaks for Earth. Currently, any amateur astronomer with a radio transmitter could theoretically send signals into space. Without a unified global protocol, we risk sending conflicting or confusing messages. Organizations like the International Academy of Astronautics have proposed guidelines for messaging extraterrestrial intelligence, but these are voluntary. In a universe where first impressions might be our last, haphazard communication could be catastrophic. And then there's the philosophical angle. If these civilizations are hiding, perhaps they've learned something we haven't, that visibility invites danger. Our own planet's history is littered with conflicts sparked by competition over resources. A galaxy teeming with advanced societies might operate under similar tensions, making stealth a survival strategy. By attempting to contact them, we could inadvertently expose not just ourselves, but them, to unforeseen threats from even more powerful entities. Yet, for all these risks, the urge to connect is deeply human. Astronomy, at its core, is the study of our place in the universe. To ignore the possibility of neighbors, no matter how distant or discreet, feels like turning away from one of science's greatest questions: are we alone? The answer, whether yes or no, would redefine humanity's future. As we stand at this crossroads, one thing is clear: the debate isn't just about aliens. It's about us, our values, our fears, and our readiness to step onto a cosmic stage where the rules are unknown. And with that, let's explore how scientists and the public are reacting to these mind-bending possibilities, shaping the next chapter of our celestial detective story. Now, as we bring this cosmic journey to a close, let's take a moment to reflect on the staggering mystery at the heart of it all. Vanishing stars, whether obscured by natural phenomena or concealed by civilizations far beyond our understanding, challenge everything we thought we knew about the universe. From the puzzling case of Tabby 6-111-1162-1 to the erratic dimming of Tabby's star, these celestial anomalies defy easy explanation, leaving astronomers and dreamers alike searching for answers. We've explored the spectrum of possibilities, from the mundane to the extraordinary. Could failed supernova or interstellar dust be the culprits? Or are we glimpsing something far more profound, evidence of advanced beings harnessing stellar energy, or even cloaking their presence from prying eyes? The truth, as always, lies somewhere between the known and the unimaginable. What makes this mystery so compelling isn't just the science, but the questions it forces us to confront about our place in the cosmos. Are we alone? And if we're not, why haven't we heard from anyone else? The Fermi paradox looms large here, reminding us that the universe's silence might be a puzzle in itself. Whether civilizations are hiding, rare, or simply imperceptible to our current technology, the search for answers continues to push the boundaries of human ingenuity. Projects like the Vanishing and Appearing Sources during a Century of Observations, or VASCO, are scanning the skies with artificial intelligence, while next-generation telescopes like the Vera-C. Rubin Observatory promised to bring even more of the universe into focus, but the deeper we look, the more humbling the journey becomes. Each unexplained flicker of starlight is a reminder of how much we still don't know and how much wonder lies just beyond our grasp. Whether nature or intelligence is behind these vanishing acts, one thing is certain: the cosmos is far stranger and far more mysterious than we've dared to imagine. So what's next? The call to action is simple yet profound. Stay curious. Support the scientists and stargazers who dedicate their lives to unraveling these enigmas. And most importantly, keep looking up. The universe is writing its story in starlight, and every observation, every question, brings us closer to understanding our role in it. Perhaps one day, we'll crack the code of these disappearing stars. Until then, let the mystery inspire you, because in a universe where even the brightest lights can vanish without a trace, the greatest discovery might not be the answer, but the journey to find it. If you enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and hit the notification bell so you never miss an exploration of the universe's biggest puzzles. Thanks for joining me on this adventure, and as always, keep wondering. The stars, and whatever might be hiding among them, are waiting.